Okay. This is a bit of a brain bender. This is something called the ambiguous case of the sine law. And what it's about is, in some cases, we can give you a description of a triangle, which is what they call ambiguous, meaning it could be taken two different ways. I'm going to skip over these diagrams for a minute and just follow along, pretending that this is all I have from the question, and you'll see how we can get into a bit of a bind with questions like this. Asked to determine the measure of angle ACB in a triangle where, okay, we have a side that's 6 centimeters long, and it's called AB. I'll do this at the bottom. So we said, okay, we have A, we have B, the distance between them is 6. Then they said AC is 4, okay, we'll come back to that, and angle ABC is 30. So coming from A to B and back out to C is a 30-degree angle. This is 30 degrees. Okay, so we've used the AB equals 6. We've used that angle ABC is 30 degrees. And the last thing we have is that AC is 4 centimeters long. Now, here's the trouble. If you want to draw a 4 centimeter line starting from here, it can go in pretty much any direction, but if it's going to be 4 centimeters long, and if it's just going to meet up with this dotted line, there's two ways that could happen. It could happen like this. That line's 4 centimeters long. Or you could also fit it if you go this way. That line is also 4 centimeters long. And we don't know which one they meant. They tell us AC is 4. They haven't given us enough information to pick between these two triangles, or we say that they haven't uniquely specified one of these triangles. They haven't said anything that could definitely tell us, no, it can't be this one, it's got to be the other one. And so that's what we call an ambiguous case. We end up standing there going, you could have meant either one of these triangles, I'm not sure which one to give you. Fair enough? Here's the same diagram up here. Brittany, let's get back to the brush. Brittany, they say, chose the lower of these two triangles, or the lower of these two lines right here. That would be the Brittany version. And so she drew this triangle, the flat, skinny one. Scott went with the taller one. His angle was off a little bit more to the left. And so he got this larger triangle. Who's right? Impossible to say based on what they've given us so far. And so in this exercise they say, check their measurements, confirm that they did everything correctly. You'll find that, yeah, these are both 30s, and the bases are both 6, and these sides are both 4, so they both measured correctly. Now, measure these angles. You can actually slap a protractor onto this page in your book, or even onto the screen of the computer if you like, and measure those angles. And I have a protractor available. Alright, well I don't have one available, but I am saved by the fact that they say, without using a measuring device, estimate the angles ACB in each case. This angle, let's see, something like that would be a 90-degree angle. And so this, is that a little more than half of 90 degrees? I'll say that's about 50. In this case, 90 would be more like that, and so we have clearly more than 90. If that's 90, another 45 here would be 135. This is maybe 140 degrees. Large question marks next to both of those because that's human eye estimation, which is lousy for measuring angles. And now they say, okay, enough guessing, now do it for real. Work out these angles using the sine law and see how much each of them is. So, actually, I'll keep my guesses up there so we can both laugh at me when this is over. I guessed that this one was 50 and that this one was 140. Now we'll do the number crunch and see how far off I was. So we're trying to find this angle C. Using the sine law, we would say sine C over 6 equals sine 30 over 4. Two opposite pairs, right? C is across from the 6, the 30 is across from the 4. Solve that, and you get sine C is 6 times sine 30 divided by 4, second sine. C is 48.5, so 49 degrees. I guess 50, not too terribly bad. Over on this one, let's see if I can be lucky twice. We get, well, same setup. It's going to be sine C over 6 equals sine 30 over 4. Same thing we got here, isn't it? Odd. We better back up. It seems like if I run this, I'm going to get 49 degrees again, and to explain why that isn't the case, we have to back up several chapters, or several units, and take a closer look at this. Here we got, I need to calculate it again, 6 times sine 30 divided by 4. We got that sine C is 0.75. Now, let's think about this. Here are some quadrants. Sine C is positive 0.75. What does that mean? It means we could be in this quadrant or in this quadrant. And either way, our sine value is 0.75. Right? Both of these are valid. This is what the ambiguous case is about. We get a sine here that could come out two different ways. It comes out with a reference angle of 49 degrees, but that could be in quadrant 1, or it could be over here. Right? Two valid triangles. What are their actual angles? Well, this first one really is 49. There we go. That's what I got for this result, 49 degrees, which is reasonable for that triangle. But here's the other possibility. We could be over at this angle, which is 180 minus 49, which is 131 degrees. That, 131, is the other version of this triangle, which also makes perfect sense. Just from the sine law, you can't tell which one of these they want because they both produce the same sine value. And so that's what we call the ambiguous case. They give you a description like this, and you get a sine value, and it gives you two possible angles, and you don't know which one to select. Sometimes we will do this to you on purpose, and we expect you to come back and say, hey, you gave me an ambiguous case, here's the two possibilities, and I don't know which one to go with. Sometimes we'll give you an ambiguous case, and then we'll give you one more piece of information in the problem, which will allow you to reject one of these triangles.